So we pick up on our conversation with solving for systems of equations by now introducing the last method for solving such systems. We call this elimination. So we've already gone through our two other methods. The first method we learned was by graphing, which ideally is based upon being able to write an equation or write the two equations in slope-intercept form and being able to get a nice clean point of intersection when we graph the two lines that result. Substitution is what we moved on to when we started getting into non-graphical methods. Substitution was a way of using algebra to solve for our system of equation by either writing one of our equations as x equals or y equals and substituting that expression into the other equation. Now, the key to substitution was that the coefficient for either x or for y in one of our two equations had to be a value of 1. Now, that is not always going to be the case. And you look down here at this system of equations, you'll see that our coefficients for x are 3 in the first equation and 2 in the second equation. Neither of those is a value of 1. And our coefficients for y, respectively, are -5 in the first equation and +5 in the second equation. Neither of those is a coefficient of 1 either. So neither of these equations would be a good candidate for us to consider for rewriting as either x equals or y equals, so we could use substitution as our method. So what we're going to want to move into now is this final method called elimination. Now, elimination is going to be a perfect alternative for us to consider when we look at our coefficients for either the x terms to see if they're the same or opposites. Now look at the coefficient for x in our first equation. That coefficient is 3. And in the second equation, the coefficient for x is 2. So those values are not the same. They're not opposites. But then we can move on to look at the coefficient for y. The coefficient for y in our first equation is -5 because it says -5y. We'll consider that coefficient -5. And for the second equation, it's +5. So by seeing that these values for the coefficients of y are opposites in this case, this makes this system of equations a perfect candidate for us to use elimination. And to eliminate means essentially just to remove or to get rid of. So we're going to be able to either add or subtract these equations to eliminate, in this case, the terms with y. And the reason why we're going to be able to focus on eliminating the terms with y is because these coefficients are opposites. So to eliminate, as I said, means to get rid of or remove, or essentially get to cancel to 0. So how could we use these two numbers, -5 and +5, using either addition or subtraction to get back to a value of 0 so that we can eliminate? Well, it seems logical that we could add the two equations together. So that's exactly what I'm going to do. So I'm going to put parentheses around my bottom equation, and I'm going to put a plus sign on the outside. Now, the reason why I am adding, this is really important. The reason why I am adding is because my coefficients are opposites. Whoops, my coefficients are opposites. So think about that. If I add -5y and +5y, that's going to make these terms cancel out when I add, okay? Now, likewise, if I were to subtract, it would be because naturally my coefficients are the same. So think about it, this was 5y and that was 5y, then 5y minus 5y would get me to eliminate, okay? So this is really key. So when the coefficients are opposites, we'll naturally use addition to get those terms to eliminate. And when the coefficients are the same, then we would use subtraction. So in this case, we are going to use addition, okay? So another key point here is to be able to add these equations. We want our like terms when the equations are stacked on top of each other. We want our like terms to be right on top of each other. So notice I have my x terms directly on top of each other. I have my y terms directly on top of each other. And on the other side of the equal sign, I have my constants, okay? So it doesn't really matter what form these equations are in, but what's important to allow us to either add or subtract is for these equations to be lined up in the same order, so that when I'm ready to add, as is the case in these two equations, I just basically add these columns of like terms. So I'm going to add 3x plus 2x. So I'm adding that column. That gives me 5x. I'm going to add, now carefully, that's negative 5y plus positive 5y. Now think about it. Negative 5 and positive 5 are opposites, so with the add, they cancel out. So that's the eliminating that we're talking about. And then I'm going to add the constant terms on the other side. Negative 16 plus 31 should give me a value of 15. Now look at how conveniently we've gotten the one term with y in both equations to cancel out, to eliminate, and for us to wind up with a nice, simple one-step equation. In this case, a one-step equation that will allow me to solve for x. So where I have 5x equals 15, after adding the two equations together, I can quickly divide both sides by 5, and I will get x equals 3. Now that is the x coordinate of ultimately what will become a solution that's represented as an ordered pair. Okay, so we're basically at the halfway point here. Okay, so now that I know what x is, this is very similar to how we dealt with being halfway through with substitution. Once we know what x is, we can take this value, substitute it back into either of my two original equations, and it's not going to matter which one, and I can finish solving for the other unknown variable. In this case, I can solve for y. So from here, I have the freedom to pick either of the two equations. I'm going to pick my second equation. The reason for it is because I only have to multiply by 2 instead of multiplying by 3 when I substitute x in, and I also don't have any subtraction here to deal with. So I'm going to take that 2x, but I'm going to replace my x with 3. So I'm going to say 2 times 3. I'm going to take my second equation, plus 5y equals 31. And I'm just going to solve through. Let's see, what is 2 times 3? 2 times 3 is 6, plus 5y equals 31. Now I'm running out of room, so I'm just going to carry this up here. 6 plus 5y equals 31. This is the two-step equation I can simply solve for. So I can first subtract the 6 on both sides, and I get 5y equals 25. And then I can divide by 5, and I get y equals 5. So I first used elimination by adding, because my coefficients for y were the same, and I got x equals 3. And then I substituted that value in for x into either of my two equations, and I got y equals 5. And then I write my final solution as an ordered pair. So our solution should be 3, 5. Now, if I quickly do the checking up here, let's see, 3 times 3, I'm just going to kind of do this in my head, okay? So 3 times 3, 3 is 9, minus 5 times 5 is 25. Does that equal negative 16? Let's see. 9 minus 25, negative 16 equals negative 16. So check. I'm now going to have to make sure it works for the second equation. So let's see. I'm going to do 2 times 3 is 6, plus 5 times 5 is 25. Does that equal 31? Let's see. 6 plus 25, 31 equals 31. I get a check. So I know that is my final solution, 3, 5. Okay, so let's quickly review before we move on to the next example, which we'll go through a little more quickly. The key points here are that the equations have to flow in the same order. Well, let's see. My first equation in my next example goes x term, y term equals constant. My second equation goes x term, y term equals constant. So are they in the same order? Yes. The next thing I need to consider is that my coefficients are the same or opposites. So coefficients same or opposites. And I mean that either for x or for y. Well, my coefficients for x are 5 and 9. Those are not the same. But my coefficients for y are the same. Okay, so that checks out. So this is a good candidate for adding or subtracting. Now, don't forget what we said back up top. So if we go back up top, what determines whether we'll add or subtract? Well, if the coefficients are the same, then naturally to get those terms to eliminate, we'll have to subtract. So that's what's going on here. So we're going to put a parenthesis around the bottom equation. We're going to put a subtraction sign, and now we're just going to subtract each column of terms. So let's see, 5x minus 9x. Now as a reminder, we're subtracting down. That gives me negative 4x. Now this is just by coincidence. We're eliminating for y again. That's not always going to be the case. I know that's what we did in the top equation as well. But 2y minus 2y, that cancels. And 6 minus 22 gives me negative 16. Conveniently, with eliminating the y term by subtracting the equations, we get a one-step equation. And here we can quickly divide by negative 4. And at our halfway point, we get x equals 4. Now from here, don't forget, this is the halfway point. This is, in this case, our x coordinate of what will be a complete ordered pair when we're all done. So we're going to need to take this value, and we'll substitute it back in for x, either in the first equation or in the second equation. It's your choice. So this time I'm going to go with the first equation because the first equation looks like the math is a little bit easier for me. So I'm going to do 5 times my x value, 4, plus 2y equals 6. Well, let's see, 5 times 4 is 20, plus 2y equals 6. As a two-step equation, I'll subtract 20 on both sides. 2y equals negative 14, and dividing by 2, I get y equals negative 7. So when I'm done, I should be happy with knowing that my solution is 4, negative 7. And we'll quickly do a mental check just to make sure. Let's see, 5 times 4. So here's my check over here. I'll just keep track of it as much as I need to. So 5 times 4 is 20. 2 times negative 7 is negative 14. Is 20 minus 14 equal to 6? Yes, 6 equals 6. So check. We have to do a second check on the other equation. We'll do this again. 9 times 4, 9 times my x value, 36, plus, let's see, 2 times negative 7. Oops, actually, that's going to be plus negative, so we can just say minus 14. Minus 14. Does that give me 22? Yeah, 36 minus 14, 22 equals 22. Check. So once again, we can be happy with the fact that our ordered pair works out to be true. So there are 2 worked out examples for you. So if you need to, go back through this video because you're going to have a couple problems to work through on a Google form that you'll show your work for, and it's going to be based upon you confirming that you know this process. So go through this video, refer back to this video as you need to, and complete the Google form that goes along with this set of notes.